Okay, so this week we're looking at inverse functions. So what that means, to take the inverse of a function is to flip it around. We want to undo whatever our original function happens to be. So let's figure out how to do it first, and then I'll explain what that means for us. Okay, so we have f of x equals 2x minus 5. So to find the inverse of that, our first step is we're going to rewrite it. Instead of f of x, we're just going to call it y. Okay, so y equals 2x minus 5, nothing fancy there. And then to do the inverse, you're going to take all of your x and y's, and you're going to flip them around. So anywhere you had a y, you're going to put an x there. Anywhere you have an x, you're going to put a y. So the inverse of this, we would say x equals 2y minus 5. Okay? And then you're just going to solve for y. You want to get y all by itself. So really the math here is just testing, do you know algebra enough to isolate our variable y? So for this one, we would want to get rid of the minus 5 first, so we'd do plus 5 to both sides. So that gives us x plus 5 equals 2y. And then we want to divide both sides by 2. And that gives us the inverse of x. That's how we write that. F negative 1, sorry. F. But you don't actually say f negative 1. Anytime you see some function raised to negative first power, you just call that the inverse of f of x. Okay, don't actually say negative 1. People will look at you funny. So the inverse of f of x equals x plus 5 divided by 2. Okay, and that's what we're going for today. So we write our function out, we replace the f of x with y, then we swap x and y, and then we solve for y. Which I know it seems like, what's the point? The whole thing is, we're saying in our original function, 2x minus 5, I can put any number in for x, and I can get an answer. And then if I put it into this inverse function, we will end up back where we began. Like if I made a table for 2x minus 5, so I say x and y, and I could say 0, 1, 2, 3, and then I fill my y values. 2 times 0 minus 5 is negative 5, 2 minus 5 is negative 3, negative 1, and then 1. Right? So now if I switch them around, if I switch x and y, and I put it into my inverse function here, and I should end up back where I started. So if I say negative 5 plus 5 is 0, 0 divided by 2 is 0, top line works. Negative 3 plus 5 is 2, 2 divided by 2 is 1, hey. Negative 1 plus 5 is 4, 4 divided by 2 is 2, look at that. And then 1 plus 5 is 6, divided by 2 is 3. So all it is, the inverse function just allows you to go from your range of a function back to the domain. Because that's one of just the core concepts of algebra, is that anything that can be done can be later undone. And that's what we're working on. All right, let's just try a couple more. So f of x equals negative 5, 6x minus 10. So we rewrite it, place f of x with y, negative 5, 6x minus 10 over 3. We rewrite this, we put x in place of y, negative 5, 6. We replace x with y minus 10 over 3. And now we're solving for y. So I want to get rid of this minus 10 thirds. So I'm going to add 10 thirds to both sides. Going to run out of room. Let's see, x plus 10 thirds equals negative 5, 6 y. Okay. And then I want to get rid of times negative 5, 6. So remember, to get rid of multiplying by a fraction, you multiply by its reciprocal. So I'm going to multiply both sides by negative 6/5. Remember, I have to do everything on the left side by negative 6/5. So that's going to give me, if I distribute this out, so that's negative 6 bits x Let's see. No, let's just do this. Negative 6 times 10 is negative 60. 5 times 3 is 15. And then 60 divided by 15 is 4. So this is just going to be minus 4. That's on the left side. Equals. And then all of this is going to cancel, so we have just y left over. And then we could rewrite this. We could say the inverse of f of x equals negative 6 bits x minus 4. And there you go. So there's nothing too super complicated. It's just, can you manipulate functions? Can you do the opposite order of operations to solve for y? Okay, one more, because this one's a little bit trickier. So we have g of x equals 4 over x plus 1 minus 1. Looks a little fancy. So I'm going to rewrite this. Y equals 4 over x plus 1 minus 1. And then I'm going to swap x and y. So x equals 4 over y plus 1 minus 1. Okay. So now I want to get y by itself. So if I have a y in the fraction, but then I have a plus or minus at the end, I need to get rid of that first. So I'm going to do plus 1 to both sides. So that gives me x plus 1 equals 4 over y plus 1. And now I want to get rid of this fraction. So I'm going to multiply both sides by y plus 1. How do I want to do this? Can I flip this whole thing over? Let's do that. That'll give me more room. So I want to multiply this times y plus 1. So then on this side, these will cancel. And then I have y plus 1 times x plus 1 equals 4. Okay. Remember our goal. We want to get y by itself. So I have this times that, right? We just have two things. Y plus 1 times x plus 1. So I want to get rid of this times x plus 1. So I'm going to divide both sides by x plus 1. Again, this is just testing your algebra skills. So x plus 1 divided by x plus 1 cancels out. And we're left with y plus 1 equals 4 over x plus 1. And then just, because you might not have seen this in a while, just so you can recognize the pattern. Anytime you have a fraction with a variable in the denominator, if you're trying to get rid of the fraction, you're always going to end up with the same kind of thing, where what's in the denominator swaps with what's on the other side of the equation. Like we see we have x plus 1 up here and then y plus 1 in our denominator. We ended up with y plus 1 all by itself on the left and x plus 1 in the denominator. Not that you should skip these steps, but as you do more of these, you start to see, oh, hey, that happens every time. Maybe I can save some work later. Okay, anyways, one last step. Remember, we want to get y by itself, so we just have this minus 1 left over. So I'm just going to minus 1 from both sides. I'm going to have y equals 4 over x plus 1 minus 1. Y is by itself, so that becomes our answer. So the inverse of f of x is 4 over x plus 1 minus 1. And then this one's kind of neat, because if you go back up to the original function, and you'll see that we ended up exactly where we started. That's just a coincidence. Don't expect that to happen very often. Ooh, this shouldn't be f of x, so this should be the inverse of g of x. Not that that matters, but it makes it look a little bit better. Okay, so good luck. Try some out. We got a couple days of practice in these, so if you're having trouble now, that's okay. Plenty of time to get better. So good luck.